All right, as we conclude this lesson, I'm about to show you a topic that I don't believe is tested, but still goes with polar graphs. Is this, how would you transfer or convert from one type of function from polar to rectangular or rectangular to polar? Well, you would use these same formulas that we used last class. So I put this slide here just to help you recall how to do so. If you wanted to switch between polar and rectangular equations, this right here is rectangular. What you would do to convert is you can, if you want, remember that y is our sine, x is our cosine. You could also, if you are dealing with multiple squares, use this formula here. What I'm going to do is I'm going to say this is equivalent to r sine. Y is equivalent to r sine, which means x squared is the same thing as r cosine squared. And how you would solve this is you would have to isolate the r value. So it would be r sine theta equals 1/2 r squared cosine squared theta. And I'm going to get my r's on the same side of the equation so I can do a GCF or factor, or excuse me, I have a squared over here. So what I would need to do, the simple way of thinking about this would be divide out an r. The truth be told, we're going to have issues if r equals 1, but I could still think about solving this equation since those are multiplying, dividing by r. There's just a problem where if r is 0, we have an issue there doing this. But now I have that sine theta equals 1/2 r cosine squared theta. What I could do is multiply both sides by 2. That gets rid of the 1/2. So 2 sine theta equals r cosine squared theta. And finally, you would divide by your cosine squared. And to clean that up a little bit, if you use your identities, I'll write it this way. This is the same thing as 2 sine theta, and then divided by cosine theta this way. Whoops, how about this? Cosine times cosine. And I'm just going to put a times 1 there. If you remember that this, it represents a tangent, sine divided by cosine is tangent. Got the division sign. And this right here, that right there becomes a tangent. So it's r equals 2 tangent theta. And this is the same thing as secant. Right here, this right here, 1 divided by cosine is secant. So it'd be 2 tangent theta secant theta. That should be my answer here. And you can check these on the graph, but that's how you would go about this process. Let me just get a brand new graphing calculator and I'll show you. If I looked at the graph, y equals 1/2 x squared, y equals 1/2 x squared, and then I graphed r equals 2 tangent theta secant theta, and I think on Desmos you have to do a multiplication symbol. Let's see here, multiply and multiply. What is it not doing? What does it say? Put parentheses around the thetas, it says. There we go. And as you can see, the two graphs look 100% the same. So we did do that correctly. If we tried part B, I would use the same substitutions. So this would be 4 times r cosine squared times r sine equals 1. Immediately, I could divide each side by 4 after substituting out the x and the y for r cosine and r sine. So when I do that, I'm left with r squared cosine theta times r sine theta equals 1/4. If I combine my like terms, I now have r cubed cosine theta times sine theta equals 1/4. And now what I'll do is from both sides, I'm going to divide out that cosine and sine. And so I'm going to write it over here, dividing out the cosine times the sine. So I'll put it over 1 like that. And so when I do this, I'm left with r cubed equals 1 over 4 and cosine theta sine theta, and I'm going to rewrite it one more time. When you have denominator cosine and sine in the denominator, that's the same thing as secant and cosecant. So I could say that r cubed equals 1/4 secant theta times cosecant theta. That could be your answer, or if you wanted to cube root it, cube root it. If I cube root each side, this would cancel over here, and r would equal the third root of 1/4 secant theta cosecant theta, and that would be my answer there. Again, we could go graph these and check it out. 4x squared, y equals 1, and then the next equation, r equals, I had the third root. Let's see here, where's the third root? Functions. There it is. Third root of 1/4 secant. I had to put a parentheses around the theta this time. I'll remember that. Cosecant theta. And we have some mistake here. I need to go back and see where I messed up, but somewhere in there it did not quite work its way out right. I'm not sure where I went wrong, but I'll have to check that out. No, I see my mistake over here. The cosine should have been squared. So all this way, that cosine needed to be squared, which means this cosine is squared, and when I divide, I'd be dividing by cosine squared. So this is cosine squared, this is a cosine squared. This becomes a secant squared, and so finally this is a secant squared. Let's see if that fixes it. So if I put it in here, secant squared, yeah, there we go. That's what we needed, and that would become my equation. Example 6c here, as I continue on, if you're working with the r by itself, the easiest way to get around this is if you square both sides of your equation. If you square both, you get r squared equals 4 squared, and r squared is equivalent to x squared plus y squared, and 4 squared is 16. That would be our solution this time around, and I can show you that. So we have r equals 4, and then x squared plus y squared equals 4. That's in not 4, 16 now. And notice those two graphs are exactly the same. So we got that one right. Okay, now theta, what could you do with that? If you're left with the theta, this is where you use your tangent. You take the tangent of both sides. So tangent theta would equal the tangent of 2 pi over 3. And tangent of theta, sine is y, cos is x, tangent is y over x. We could substitute and say that's y over x equals tangent 2 pi over 3. That if you use your hand trick, you bend. 2 pi over 3, by the way, is in the second quadrant, just as a reminder. 2 pi over 3 is in the second quadrant, which means tangent would have a negative slope. This is going to be a negative value. 2 pi over 3 is here in the second quadrant, so it will be a negative tangent value. I bend my index finger, I flip my hand for the pi over 3. I have square root of 3 for y's, and my x would be negative square root 1. That could simplify to be the square root of 3 over negative 1, which is equal to the negative square root of 3. If that's the case, to finish this off, y over x equals the negative square root of 3. All you have to do is multiply both sides by x, and you have your equation. And this will be that y equals negative, square root of 3x. As I mentioned, tangent is the slope. It was a negative slope. That's the negative slope right there, negative square root of 3. I don't think Desmos will graph theta equals 2 pi over 3. You should know that one though, but I will graph y equals negative square root 3 x. Notice that would go right through where 2 pi over 3 is located right there. That should be where the 2 pi over 3 is located. Two more. R equals 6 cosine. On this one, I would do this a little differently. I would multiply both sides by r. If I multiply both sides by r, let me write it out like this. R times r equals, how about r times 6 cosine theta? The reason I would write it this way is this is r squared. This becomes 6r cosine theta. R squared, if you remember, is the same thing as x squared plus y squared. That's Pythagorean theorem. And r cosine is x. So you could leave it in this form. A lot of times what we actually do in math is we would subtract over the 6x and we would complete the square. So when I do this, when I subtract that over, I would have x squared minus 6x plus y squared equals now 0. And what many mathematicians do is they complete the square. If you remember this process, you take your b value, you divide it by 2. So negative 6 gets divided by 2, which equals negative 3. And then what you do is you take that value and you square it as you go back in. Negative 3 squared is plus 9. If I add 9 on the left, I need to add 9 on the right. This right here will simplify to be x minus 3. It's this number right there, x minus 3 is quantity squared plus y squared equals 0 plus 9 is 9. That's going to be the equation here in rectangular form. And if I graph these two, they should be one and the same. We knew this is a circle, if you remember from earlier today. So r equals 6 cosine theta. And we just came up with, whoops, what in the world? Let's try this again. X minus 3 quantity squared plus y squared equals 9. Notice that's the exact same circle. So we did that right. All right, I have one more. This is basically kind of doing the opposite of what I did a moment ago. Here, what you would have to do is you'd have to FOIL out this math. You'd have to expand it. So here, if you're squared, it'd be x times x. First times first, then the x would multiply times the negative 3 in the second parentheses. Let me just write it out twice so you can see what I'm talking about. This would be x minus 3 times x minus 3 plus y minus 2 times y minus 2 equals 13. And so when I multiply this, I would have x squared. I'm FOILing or distributing. I'd have a negative 3x, a negative 3x, and a positive 9. Over here, I would have a y squared that's being added, positive y squared, a negative 2y, another negative 2y, and finally, I'd have a positive 4 equals to 13. First thing I would do when simplifying this is I would combine some like terms together. Here I can see that I'll definitely have a negative 6x, I'll have a negative 4x. This 9 plus this 4 is going to be 13. I'm going to actually, as I do this, I'll just subtract 9, I'll subtract 4, which means I'm subtracting 13 from both sides. Subtracting 9 and subtracting 4 is subtracting 13. All of these simplify out of there. I'm left with x squared minus 6x plus y squared minus 4y equals 0. And I'm going to group my x and y, x squared and my y squared together. And then I'm going to have a negative 6x and negative 4y after equals 0. And now I'll substitute. X squared plus y squared is r squared minus x is the same thing as r cosine. And y is the same thing as r sine theta. Here, what you could do to try to simplify this, if you wanted to, you could factor out an r from here and say this is r. If I factored out the r, you'd be left with r minus 6 cos minus 4 sine. If you wanted to write it that way, you could. I don't know which way would be more proper on this one. You could leave, I'm going to leave it like this, but this equation would be the same exact thing. If you want to try one, go by all means, go for it. But either way, try DOL number 2 on the back of the packet. DOL number 2. Now, once you've completed DOL number 2, make sure you submit everything in online.